All right, so this is where we ended on Wednesday. We did two of these examples, one with scale changes, one with translations. So what you have on your paper now is we're just going to put all of those rules together. So we're going to do two graphs that has both scale changes and translations in them, so you can see kind of what one big one's going to look like. All right, so before we do anything in any of these problems, we need to make sure that our equation is in that proper form that matches our transformation chart that we talked about before. And that means there should be nothing multiplied by your x. If there is, like there's a 1/3 technically multiplied by my x here, I need to factor that out of the parentheses. So I'm going to do that first just to get it in the proper form. All right, so that's going to look like 1/2 cosine. I'm going to pull the 1/3 out. Dividing by a third is the same as multiplying by its reciprocal 3. So you can imagine doing that to everything in the parentheses. 1/3 times 3x just leaves me with x. And pi over 3 times 3 would just leave me with pi, and it'll be negative. You can mentally distribute that 1/3 back in to make sure it works. And then don't forget the -1 at the end. Okay, so just getting it in the proper form. Okay, rules from Wednesday. I know it's been a while. So scale changes are, I'll do it up here, reciprocal of b times x, a times y. You have that in your notes. What's the reciprocal of b here? Reciprocal of b. What is b? 1/3. So the reciprocal of that is 3. Okay, what's a? 1/2 is going to get multiplied by my y. So that's going to do a horizontal stretch by 3 and a vertical shrink by 1/2. Your translation rules are x minus c, y plus d. So here, and this is why we had to factor that 1/3 out, it changes my c value. It's going to be an x plus pi. It's going to be the opposite sign from what you see in your equation, and a y minus 1. Okay? What's the phase shift? Remember that? Or how to find it? Opposite of C, which here is positive pi, which is a fancy way of saying it's just a horizontal shift. It's going to move right pi units. Okay, key points. What radians do we use for our key points? Where do we start? Think about your unit circle. What angle do we start at? 0. And then as we went around, we used radians. It's every 90 degree, every quarter rotation. So 0 to pi over 2, then pi, 3 pi over 2 at the bottom, and back to 2 pi. Now the second part of the coordinate, you're going to use the function that you're graphing. Here we are graphing a cosine function. So you need the cosine of each of these radian measures. Again, you can use your unit circle. What is the cosine of 0? 1. What is the cosine at pi over 2? Pi. 3 pi over 2 and 2 pi. 1. Okay, so we're not memorizing those. They're just coming off of our unit circle, either a cosine or a sine. All right, so now let's do the math. We do our scale changes first. So we're going to multiply our x's by 3 and our y's by 1/2 that we set up. So my x's by 3 will give me 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. 1/2 times my y's, give me 1/2, 0, negative 1/2, 0, 1/2. Okay. And then my translations, again, we have the rule set up. We've just got to do the math now. We need to take our x's and add pi, our y's, and subtract 1. Okay, so all my x's plus pi. 0 plus pi gives me pi. 3 pi over 2 plus pi. 5 pi over 2. If you need to write that out, do the math with the common denominator, that's fine. 3 pi plus pi is 4 pi. 9 pi over 2 plus pi, 11 pi over 2. And 6 pi plus pi is 7 pi. On my y's, I'm just going to subtract 1. 1/2 minus 1 is negative 1/2. 0 minus 1, negative 1. Negative 1/2 minus 1, negative 3/2. 0 minus 1, negative 1. 1/2 minus 1, negative 1/2. Okay, and then that's what we're going to graph. Now you'll notice my points are going to go up to 7 pi. My graph right now only goes up to 4 pi. So I'm going to renumber my axes here. Instead of counting by pi's, I'm going to count by 2 pi. So I'm going to make that 2 pi, 4 pi, 6 pi, 8 pi, just so I can squeeze it all in there. Okay, you could always extend your axes too if you had room. Okay, so at pi, I need to make a point at negative 1/2. Okay, so right about there, halfway between 0 and 2 pi. 5 pi over 2, which that's like 2.5. I'm at negative 1, probably about there. At 4 pi, I'm at negative 3/2 or negative 1.5. At 11/2, which is like 5.5, if you think of the decimal, that might help. I'm back at negative 1. And then at 7 pi, halfway between 6 and 8, I'm at negative 1/2. So that is 1 period of my function, arrows on either side. Just make sure your arrows don't go any higher than negative 1/2 or any lower than negative 3/2. We're going to bounce between those two numbers forever if we were to extend this graph. Okay. Good there? Okay. Period of this graph is the length of one wave. You can actually see it in the points if you want. I started at 0 or at pi and I ended at 7 pi. What's the length of the wave? 6 pi. Now, if you need to, you can always do 2 pi divided by b, which here b is 1/3. Dividing by 1/3 is the same as multiplying by 3, so that would also get you the 6 pi if you want to do it that way. Amplitude is half the height of the wave or the absolute value of a. Either way, you're going to get 1/2. Domain is always all real numbers. Range we can see in our picture is negative 3/2 to negative 1/2. And I'm going to add one more thing on here, one more property. I'll put it above the word property. Sinusoidal axis. Sinusoidal axis. Sinusoidal axis is a horizontal line that goes right through the middle of your wave. There is a formula for it. It's actually just our vertical shift. You can use y equals d. Y equals, because it's a horizontal line, d being the vertical shift that we have, and here it was negative 1. Y equals negative 1, which you can see in the picture. That would be a horizontal line that would go right through the center of our wave. So you can use a picture or you can use an equation. Okay. All right, you guys have your graphing calculators? I want to show you how you can check this. Which this is on the back of your paper. Some of the modes we'll use, just so you have them written down, but we'll do it with this one. There we go. Okay. So first of all, double check that you're in radian mode. You probably aren't, I have a feeling, because we're doing degree homework. So we want radians when we're graphing these. That's what our x-axis is. All right, so go ahead into y equals, and let's put this equation in there. And you can put the original version of the equation, is fine. Just use the alpha y equals when you get to a fraction. There we go. Okay, so alpha y equals, enter, 1/2. Cosine sets up the parentheses for me. Alpha y equals, enter, x over 3 minus alpha y equals, enter, pi over 3 end my parentheses, minus 1. Okay, good there? Got the equation in, it's in radian mode. The only other thing you have to do is you need to change the window to match the window that we have graphed this on. So what we're going to do is we're going to hit window, it's right next to y equals, and we're going to change these settings to match what we have in our picture. So what we see will hopefully be exactly what we have in this picture. Okay, so our x min, let's set that to negative 2 pi. We counted by 2's. Okay, that's fine. When you hit enter or go down to the next line, it's going to multiply those together. So you're going to see negative 6.28, which is negative 2 pi. Okay. X max, the highest x value we have is an 8 pi in this picture. And then x scale, that's what we're counting by. We're counting by 2 pi's on this x-axis. Okay. My y's are negative 5 to 5, so my y min, negative 5. My y max 5, and my y scale is 1, and then the rest of it you don't have to change. Okay, so we're just matching it to what we see in our picture. That could change from problem to problem. Math Excel, you might have to adjust those values a little bit. Hit graph, and you're going to see a really nice picture that looks really similar to what we have there. Okay, so this can be pretty helpful in Math Excel. You guys also have Desmos as an option, but you're going to have to do the same thing in Desmos with the x-axis and the y-axis. I honestly think it's easier in the graphing calculator just to do it because of the way the settings are there. Now, if you get stuck with those window settings, all you'd have to do is hit zoom 6 and it'll take it back to your regular window. Like if there's an error happening or something, just zoom 6 back to your standard window and it'll reset it all for you. Okay. Any questions? No? Okay. We just have one more graph we're going to do together. We're going to do this one. Y equals 3 sine 2 pi x plus 4 pi plus 3. Is my equation in the proper form? No. What do I have to do? Factor out 2 pi. All right, so let's do it. 3 sine, if I take 2 pi out, what am I left with? Dividing both of those terms by 2 pi, I'll be left with x plus 2 pi times what gives me 4 pi? Just 2. Okay. Scale changes. Reciprocal of b times x. What's the reciprocal of b? It's going to be 1 over 2 pi. Even the pi is going to be in the bottom, multiplied by x. And then a times y. What's my a value here? 3 times y. My translations, x minus c. So x, what am I going to put there? What's my left-right shift? X minus c. What is it? Minus 2. And then my vertical shift is y plus 3. What's the phase shift? Negative 2. Good. Okay. Key points. Start with those same radian measures. Every quarter rotation around our unit circle. 0, pi over 2, pi, 3 pi over 2, 2 pi. Only difference now is we are graphing the sine function. So at each of those radians, think about your unit circle. We want the sine at each of those values. What is the sine of 0? 0. What is the sine of pi over 2? 1. Sine of pi. 3 pi over 2. And 2 pi, 0. Okay, do the math. We're doing 1 over 2 pi times my x's and 3 times my y's first. That's my scale changes. Well, that's going to give me 0. If I do pi over 2 times 1 over 2 pi, what cancels? The pi's, and what are you left with? 1/4. Correct. Okay. If I do pi times 1 over 2 pi, what am I left with? 1/2. If I do 3 pi over 2 times 1 over 2 pi, 3/4. And then if I do 2 pi times 1 over 2 pi, 1. So how many pi's left? 3 times my x is 0, or my y is 0, 3, 0, negative 3, 0. There we go. Okay? Because the pi's are gone, this next part's going to be easier. X is minus 2, y is plus 3. Negative 2. And you can use decimals if you want to. Like this one, I'll probably use a decimal. Negative 1.75, negative 1.5, negative 1.25, and negative 1. They're exact. That's fine. All my y's plus 3, I get 3, 6, 3, 0, 3. Okay. You can graph this if you want on the current graph paper. If you don't want to renumber it, you just need to think about pi as the number 3.14, 2 pi as the number 6.28, right? Okay, so you can do it that way. Or you can renumber it if you want. If you don't want the pi's at all here, that would probably be fine. Like you could just think of it as negative 2, negative 1, 1, 2, 3, 4. It's still radians. We're just counting by something different. We're not counting by pi's. Okay. And then graph your points. So negative 2, I'm at 3. I'm going to be up there. Negative 1.75, I'm at 6. I'm going to be a little above my graph. Negative 1.5, I'm back at 3. Negative 1.25, I'm at 0. And then back at 3. And there's my 1 period of the graph. Okay, so if you wanted to, you could check this with the calculator. You would just change that x-axis in your window to match what you see in the picture here. Okay, properties, period. You can do 2 pi over b, or you can find the length of the wave. How long is this wave? This one's not too bad. From start to finish, it's how many units wide? 1. Yep, that's it. Okay, or you could do 2 pi over b, which is 2 pi over 2 pi, which gives us 1. Amplitude, what's the amplitude of this wave? 3. Half the height of the wave, or absolute value of a. Domain is always all real numbers. Range we can see in our picture is 0 to 6. And then let's add that sinusoidal axis one more time. It's y equals what? What cuts right through the middle of that wave? 3. Y equals d, your vertical shift. Okay, so when you guys get to Math Excel, most of the Math Excel, you're not going to be doing like all these key points and stuff. The instructions will say, use the 6-step method to graph, and then you're pretty much going to be matching the graphing part of it, okay? There might be a couple problems. I put a little picture at the bottom of your handout there on the back. Do you guys remember using the sliders last semester with the parent functions? You might have to use those again. You might have to select if there's been a reflection or a vertical shift, that sort of thing, and they might do it that way for a couple problems. This homework assignment is due on Monday night. Okay, so 5-4 is due on Monday night. Monday, if you want to do your unit circle retake, you can before and after school, and then circuit training will be due on Wednesday. All right, we've got 20 minutes. So here's what we're doing for the last 20 minutes. I have an exit ticket for you for 5-4. 1, 2, 3, 4, 5. You may turn this in before you leave, or you can turn it in Monday when you come back to get a little extra time. That's fine. But I am selecting this for a grade, mostly a completion grade, probably we're going to do. Okay, but you can use your notes from the last 2 days to help you do these 2 problems. All right, so you got 20 minutes. Try these 2. If you get it done before you leave, drop it in the tray. That's fine. If you need a little more time, you can give it to me on Monday.